One of the things chemists are interested in is the changes that matter undergoes. So we can group these changes into physical changes and chemical changes. We'll talk about the physical changes first. State changes. And this is not moving from California to Minnesota. This is changing physical state. What were the 3 states of matter that we talked about? Solid, liquid, and gas, right? So a state change is changing from one state to another. So melting is changing from a solid to a liquid. Sublimation is changing from a solid directly to a gas. State changes are always physical changes because they do not change the composition of the substance. So when we have a physical change, the matter can change in its appearance, but not in its composition. So ice melts, it looks different, but the individual pieces, the molecules of the water are the same. In a chemical change, the matter does change its composition. So copper turns green upon continued exposure to air. The Statue of Liberty is covered in copper, but it doesn't look like a bright, shiny copper penny, does it? No, because it's out in the elements, and it develops this patina, right, this kind of greenish color, and that is the copper has reacted with water and oxygen in the air and formed new compounds. And unlike rust, which flakes off, that coating on copper stays there, and so it actually protects the copper from completely decomposing. So that is a chemical change. There is a correlation between physical properties and physical changes, and between chemical properties and chemical changes. A chemical change is a chemical reaction. Now that sounds more like chemistry, right? So in a chemical reaction, the substances that you start out with are called the reactants. And the substances that you end up with are called the products. So we've got reactants to start with, and then products. And we often represent chemical reactions with a chemical equation. It's similar to a math equation in some ways, but instead of an equal sign, we have an arrow. And so we start with the reactants, and the arrow points to what happens, the products. The reactants react to produce the products. Because the substance has changed, this is a chemical change, not a physical change. So the difference between these changes we see at the particulate level, looking at the individual particles. Physical change results in a different substance. I'm sorry, scratch that, that's absolutely wrong. Physical change results in a different form of the same substance. You take a piece of wood and you cut it in half. It's changed, right? It's smaller. You took that 10-foot 2x4 and you cut it in half, and now you have 2 5-foot 2x4s. There's a change that has occurred. But are the 2x4s still made out of wood? Yes, they are. That's a physical change. If you take the 2x4 and you burn it, that is a change. But that's a chemical change. It's not wood anymore. You've got ashes and carbon dioxide and water that have gone off into the atmosphere. Okay? So chemical change gives us a new substance. A physical change just alters that substance in some way, but it's still the same substance. Here's an example of a physical change. So here is a butane lighter. Inside we've got liquid butane, and when you press down on the lever without striking a spark, what happens is the liquid butane is released into the gas phase, and it begins to come out of the lighter. If you just hold a lighter like that, eventually it will be empty because all the butane is going to come out. You can't see that happening because gases are hard to see, but it does happen. You see, these particles are the same as the particles in here. This is a physical change. It's gone from a liquid into a gas, so it's different. This is wet, and you can see it. This is not a liquid. You can't see it. It's going to take up a much larger volume. So there's a change here, but it hasn't altered what the substance is. Now, if you do the same thing with the lighter, but this time you get a spark, now you've got a flame going on here, right? The butane that was a liquid in here is still coming out as a gas, but when it encounters this spark, it begins to burn. And it's converted into carbon dioxide and water. And now the particles have changed. And so this is a chemical change. You see the difference? Chemical change, physical change. Ooh, here's a question. In lab, we talked about evidence for a chemical reaction. There were 4 different things. What do we see here that's evidence that a chemical reaction is happening? Heat is given off. Heat and light are given off. And so that's an indication that this is a chemical change. So let's look at these examples. Determine whether each is physical or chemical. The rusting of iron. Chemical. The evaporation of fingernail polish remover from the skin. So acetone, you take your fingernail polish off and the acetone evaporates from your skin. Physical. A clue here is this word, evaporation. That's the name of a state change. So this is a physical change. The burning of coal. Chemical. The fading of a carpet upon repeated exposure to sunlight. So there's some dissension there. What was one of the other evidences of a chemical reaction? It had to do with color. A permanent color change is evidence of a chemical change. So the fact that the carpet has faded indicates that a chemical change has occurred. Now, the carpet is still carpet, but if you were able to look at the dyes in the carpet and look at their structure, you would see that they have changed, and that's why it's a different color. So this is a chemical change. Mixtures can be separated through physical changes. A chemical change is a chemical reaction, destroys the substance. But if we just separate 2 things that have been mixed, the particles remain the same, and so it is a physical change. There are different ways that we can do this, and there's a whole area of science devoted to separating things that are mixed together. Distillation is one way to separate liquids. So here we have a mixture of liquids, and if we heat this up and cause the liquids to boil, they're going to boil at different temperatures. Those are physical properties. Water boils at 100 degrees Celsius. Ethanol boils at a much lower temperature. So if you had a mixture of alcohol and water, the alcohol would boil first and go into the gas state. Now, if we're wanting to separate this and retain both of the compounds, we can't have this just be open to the atmosphere or it's all going to escape. So it's all closed in here, and that gas travels through a condenser, which is a double-walled glass tube, and we've got cold water running through the outside portion, and so that cools the gas, which causes the gas to condense. It condenses back to a liquid, runs down here, and we collect it in this flask. So the alcohol will come off, the more volatile liquid will come off, and the water will stay behind. And so that's what you heard of moonshine, right? way back, a long time ago, Prohibition, it was illegal to make, serve, consume alcohol. And so, people weren't happy about that, so they went off in the woods and they made their own. Well, how do you make alcohol? You ferment stuff. But then you want to separate the alcohol from the mash, all that nasty decomposing stuff. And so spirits like vodka and rum and whiskey and things are made by distilling them. They're called distilled spirits. And you do that in a way like this. Of course, they used big kettles and stuff, but occasionally there were explosions and fires, and it's kind of dangerous. It's kind of like the old version of a meth lab, right? And every once in a while you hear about this house that has exploded or something. But you can separate them. The alcohol and the water, the particles are still the same, we've just separated them. Filtration. You probably do filtration at least a couple times a week in your kitchen. If you make coffee, if you boil spaghetti, a lot of different cooking techniques involve filtration. So filtration separates a mixture based on the differences in the physical states. So here, if we have a mixture of a solid and a liquid, and we pour it into a funnel with a piece of filter paper, the filter paper will trap the solids, but allow the liquids to go through. In fact, this is one way to make coffee, is to mix the coffee grounds with boiling water and then pour it through a coffee filter. The coffee filter catches the grounds and allows the liquid to go through. You are separating these things based on their physical properties and their physical changes.